Direct Mathematics, Notes and Examples, Functions and Graphs. This is lesson number 2, Restrictions on the Domain of a Function. So our definition of a function was that there should be a mapping from every element in the domain to one and only one element in the range. But it's sometimes necessary for us to restrict the domain, the values of x that we can put into a function, in order to ensure that a stated function is actually valid. So let's look at some common examples of the kind of problems that we might encounter around the restrictions of the domain. So our first example is f of x equals 1 over x. And we can see here, after the comma, x is not allowed to be 0. Other than that, x is any real number. So why can it not be 0? Well, of course, we cannot divide by 0. So x equals 0 would be a value that would not be permissible, and that is a restriction on the domain of the function. We write that as we've done here. In a similar way, we look at f of x equals 1 over x plus 5. Again, we can't have the denominator equaling 0. What would make that 0 on the bottom? It would be negative 5. So x is not allowed to be negative 5. Those two are the same idea. Let's look at another idea that's important. We know that in mathematics we cannot take the square root of a negative value. So here we have a function f of x equals the square root of x. Here we must say that x must be greater than or equal to 0. Otherwise, it would be negative and we wouldn't be able to evaluate that function. So that's another restriction on the domain, that we cannot square root a negative. And that idea can get quite complicated if we look at an example like the last one that we're going to have at the moment. So f of x equals the square root of 4 minus x squared. Can you see why the restriction here is that x must be bigger than or equal to negative 2, but less than or equal to 2? So maybe pause the video, have a think about it. And you might be able to think about some values. And hopefully you can see that if we take a value that's outside of that range, for example, negative 3 squared would be 9, and 4 minus 9 would be a negative. So we wouldn't be able to evaluate the function. We'll look at that example in a bit more detail in the next slide. So those examples covered two ideas that we need to consider in this course, two important conditions that we have to think about. So we'll look at those one at a time, the condition and how we find the restriction. So the first idea was that we cannot divide by 0. To solve these kind of problems, we set the denominator equal to 0, solve for x, and that will be the value that x cannot equal. And the other condition was that we cannot take the square root of a negative number. If we're presented with a problem like this, we need to consider what values of x will lead to any term inside a square root becoming negative, and those are the values that we cannot actually allow x to take. And this will be best illustrated with some example, an example and some practice. So here's an example that will combine both ideas. We're considering the function f of x equals 1 over the square root of x squared minus 25. So the question would be, what restrictions must we state on the domain of this function? So really we need to focus on both conditions here, on the two ideas. We know that we cannot divide by 0, and we know that we cannot square root a negative. So we focus on the term inside the square root, which of course is also in the denominator. And we need to think about both those situations. So first of all, we'll consider the fact that x squared minus 25 cannot be 0. So I'll write that down, that x squared minus 25 is not allowed to be equal to 0, so it must not equal 0. And we'll solve that. We know that that means that x squared cannot equal 25. And then, of course, that means that x is not equal to plus or minus 5. So thinking about dividing by 0 leads to that answer, but that's only part of the solution. We now need to consider the fact that not only can it not be 0, it's not allowed to be less than 0. So we're now saying that x squared minus 25 should be greater than or equal to 0. And we know, of course, that it shouldn't be 0, but let's think about this separately and then combine both ideas. So this is actually a quadratic inequality. And we've solved these in a previous chapter. We would look to factorize the left-hand side. So this would be two brackets multiplied together, and you'll see quite quickly it's a difference of two squares. So we've got our x and x, plus 5 and minus 5. And the best way to solve these quadratic inequalities would be to produce a quick sketch, unless you're able to work the answer out just by thinking about it, which you might be able to do with some practice. But a quick sketch, we know that we have the critical values where x equals 0, that would be -5 and 5. So we can plot those 2 points, the roots of this quadratic. We can sketch the parabola. We know that it's a U shape. And we can think about what we're interested in. We're interested in when is this quadratic greater than or equal to 0? Well, it's going to be greater than 0 for these shaded regions where x is less than -5 and greater than 5. And of course, it will be 0 at those points. So that leads to the answer that x must be less than or equal to -5 and x must be greater than or equal to 5. But of course, if we combine these two ideas, then we need to see that we cannot allow x to be -5 or 5. So in fact, the final answer would simply be that x must be less than -5 and x must be greater than 5. And that would be the answer to this particular problem. That would be the restriction, the domain of this function for it to be valid. Only with a little practice will you be able to pick up this idea successfully. So I suggest you look for questions that ask about restrictions in the domain, and they will appear in the next part of this particular topic, composition of functions.